Hello everyone, welcome to the class. Today we will talk about the FIFO. The FIFO is what? FIFO is a name pipe. So we already covered the unnamed pipe like in other video. So for unnamed pipe, it's only supports the process in the same process hierarchy, right? So which means you cannot easily communicate to other process out of your family. And today let's talk about name pipe. So what's a name pipe here? So actually we have a name pipe called FIFO. FIFO is one way we can do the inter-process communication. So what's a FIFO? You can imagine that the FIFO is actually one file. So if you use a FIFO, you create a special file, special pipe file in your program, and you can give a name. For example, I can give a name called my pipe. At least my pipe is a FIFO, is a pipe special type files in your systems. So when you check on your system, you can see this file. You can actually see this file. It's not a test file. It's only for the communication. So which means your kernel has some way to manage it. You cannot easily update. You cannot easily to write something into it because everything you write to it, it should be a pipe direct to some other file. Okay, so to direct to some other process. So this is called FIFO. You can imagine that you create a file in your system and you just try to write data into the file and another process read the data from the file. So use the file to do this communication. But this file is special because the type of this file is FIFO. So you kernel have some way to optimize this communication for you. So how to create a FIFO? Actually, in your kernel, in your system, you can type make FIFO. This you can just type it like this command. You can also use make FIFO as a system code. This make FIFO system code, the first one is the name, the file name you want to create it. For example, in this case, the file name is my pipe. The second parameter, the second argument is the permission bit. So you can see what's the permission bit for this file. So if you know what's the permission actually in the system, in the Linux kernel, in the Linux system, each file has some permission. So used to decide who has a permission to read, write, and execute this file. So this is a permission bit for the file. So in this case, if you want to use the system code, you need to provide two information. One is the file name, another one is file permission. So after you create this file, you can use this special file to communicate. You can write data into the file, and if other process read the data, try to read this file, open this file and read it, it will read the message pass it by your the process. So you can use this special file to communicate to other process. So let's look at this example. So this example is very similar to what we have for in other videos. So actually we have a main function, and inside this main function we use the fork to create the child process and parent process. But here we don't use unnamed pipe. For unnamed pipe, you need to create an array and with two elements like a two space, and use pipe this system code to manipulate this array, make its reference to the file descriptor, point to the file descriptor, right? But here it's not. Here we just use make FIFO, then we can create our pipe. So when we create our pipe, we use this pipe to communicate. How? In here, we run the child task and parent task. So actually, if you look at the child path, you look at the child task. In the child task, we try to open the pipe. We open the name. We use the name of this pipe, actually the name of the file. We open it, then we can read the data from this pipe. Also, in other process, we can open it as a write files. We write the data into the pipe. So here we try to send the same information, hello from parent. We try to write into this pipe file, actually my pipe, this file. Then this data will be sent out to another process. It's not only support the child and parent two process, it support like other process too. So I will show other information later, but let's focus on this example right now. Okay, so we have a file called FIFO. Then we generate a SQL file. So when we execute the SQL file, you can see we got the message parent sent a message to the child, sent 19 byte, and child received all the byte. And this message sent from the parent. If you look at the file name here, actually the my pipe is a special file here. We can look at the detail, and you can see the this is a special type. The P here means a pipe. The this file has a special type P. Let's see another example. Since we have this my pipe, right? So right now we can actually write some information here. So we can do echo. We try to send some message into it. We can send the message Joe into this my pipe, and means we try to set this process to the background because this process try to send the information to the pipe. Okay, so right now we need another process to receive this data. So we can get cat. Cat is a process. It's try to cat the information inside this file. So I cat the pipe, my pipe here. You can see the information we have. We give you is Joe. And after it's received data, your first process just got complete because the first process just sent your data and finish. We wait. It's wait because we want to receive the data. If we terminate this process uh, before we receive data, then the data will be disappear. So it's not like a regular file. Regular file, when we write the data into the file, the data will contain, like will be included in the file, right? But it's not. This is pipe. So you need two process like a running like together. Then you one process to try to write, another process try to read from the pipe. So this is how you use this name pipe to do a communication between two process, even though these two process has no relationship with each other, like a cat and the echo. They are two independent process, right? But they can use the same name pipe to communicate with each other. This is a short video. This is for today. And we just talked about how to use a name pipe to support the communication. The difference between name pipe and unnamed pipe is that the name pipe, you can imagine that you create a file in your systems. And because you have a file name, so every process knows this file name, they can communicate with this file. But unnamed pipe is not. Unnamed pipe you created only use your file descriptors pointers point to this unnamed pipe. So it does not like include like shows up in your system. So you can only use it to communicate to the process already know this file descriptor. So who can know this file descriptor? You know you have to have some relationship. For example, your child, your parent. So this is a critical difference. The this is very like a different parts in like between the named pipe and unnamed pipe. And for unnamed pipe, you also need to be careful about it. It's about because for the named pipe, the process one can send a message to a process two with the named pipe. The process two can also send a message to a process one with the named pipe. You need to guarantee the sending process, the don't don't do like a two process send a message to the same pipe together. Otherwise, you will get like a totally like a broken message. You cannot guarantee. So even though both process can send message or receive message from the same name pipe, like my pipe, you should still make sure it's a one direction communication. You send the message from process one to process two. Then the process two send a message to process one. So you need to some synchronization methodology uh, to control this schedule. So just keep in mind if you want to use the same pipe to do this communication, uh, you can use, of course, you can use this name pipe, but be careful. You need to make sure you like control the schedule very well, correctly. Otherwise, you will get the message messed up. Okay, so this is for today's topic. We cover the name pipe today, and you can see it's really useful if you want to use use this stuff to communicate some other process you are not aware of, then try it. Okay. So I hope you enjoyed today's video. See you next time. The FIFO is interesting.